Welcome back to Code with Festus. At this point in the Python series, you've already crossed an important threshold. You know how to store data. You know how Python makes decisions using control flow. You know how loops allow programs to repeat actions. But now, here's a new problem. As your program grows, your code starts to repeat itself. Logic appears in multiple places. Files become longer. Small changes start to break things you didn't expect. This is where many beginners hit a wall. Functions are how you break through that wall. In this video, we are doing a full deep dive into Python functions, not just how to write them, but how to think in functions the way real programmers do. We'll start with the fundamentals, then move into practical, real-world use cases, and finally see how functions naturally lead into organizing your code with modules. By the end of this video, your programs will feel cleaner, simpler, and far more professional. What is a function? A function is a reusable block of code that performs a specific task. Instead of writing the same logic repeatedly, you write it once, give it a name, and reuse it whenever you need it. Imagine a classroom. A student walks in. The teacher says, "Hello, welcome to class." Then another student walks in. The teacher says again, "Hello, welcome to class." And again, and again. The teacher is repeating the same behavior. A function is like giving that repeated behavior a name. Instead of manually greeting every student, we define a greeting routine. A function generally follows this pattern: input, process, output. In our analogy, input, a student enters. Process, teacher greets. Output, greeting is spoken. Think of a function like a machine. You give it input, it performs some work, it produces output. This input process output model is everywhere in programming. Once you understand this pattern, functions start to feel natural instead of abstract. Why does functions exist? Without functions, programs become difficult to read, debug, and understand. Consider the teacher repeating these lines up to 20 or 50 times. Print, "Hello, welcome to class." Print, "Hello, welcome to class." Print, "Hello, welcome to class." This works, but what if the greeting changes? Now the teacher must update it everywhere. Functions allow you to reduce repetition, group and organize related logic, make code easier to understand, fix bugs in one place instead of many. Professional software relies heavily on functions because humans need structure as much as computers do. So how do we define a function? Now let's create a function to perform the greeting. Def, greet, open and close parenthesis, colon. Print, inside indent, "Hello, welcome to Code with Festus." The keyword def tells Python you are defining a function. Greet is the name of our function and should describe what the function does. The indented block is the function body. Defining a function does not run it. It simply tells Python that this function exists. So how do we call a function then? To use a function, you call it by name, greet, with open and close parentheses. This tells Python to execute the code inside the function. Keep in mind, defining creates the function, calling uses the function, parameters and arguments. Functions become powerful when they accept inputs. In our greet function, we can make it accept the name of students. So instead of generic "Hello, welcome to Code with Festus" for every student, we can redefine the function. Def greet, open parenthesis, name. Print, F, open string quotation, "Hello", curly braces, name, "Welcome to Code with Festus". Greet, Festus. Greet, Sarah. Greet, Alex. Here, the name in the function signature is called a parameter. The actual value you pass in, Festus, Sarah, and Alex, is an argument. Parameters allow a single function to handle many different situations. Don't forget, defining creates the function, calling uses the function. So how do we add more context? Functions can have 0, 1, or multiple parameters. Instead of always hard coding Code with Festus, we can introduce a subject parameter. Now, we expand the function. Def, greet, open parenthesis, name, comma, subject, close the parenthesis and add your colon. Then print, F, open string quotation, "Hello", curly braces, name, "Welcome to", curly braces again, subject. Hence we call it like this: greet, open parenthesis, Sarah, comma, Python tutorial. greet, Alex, Django tutorial. This gives output as seen in the terminal. Don't forget, one function, many possibilities. Python don't just perform actions, they can return results. Imagine we want to save student greetings as attendance records. We can achieve this by simply using return keyword where we previously had print. Hence, dev greets name, subject, print hello name, welcome to subject. Now becomes dev greets name, subject, return hello, welcome to subject. If we now call this function as greeting equal to greet Sarah Python tutorial, the return statement sends a value back to where the function was called. Hence, greeting will now have the value returned by greet assigned to it. To verify that our function returns the needed value, we can now print the value of greeting. Print greeting. Note, once Python encounters a return statement, the function stops executing. Returning values makes functions reusable and testable. So what's the difference between print and return? Be aware that print only displays information to the screen. Return sends information back to the program. Key differences and considerations. Use print for visual output, quickly previewing variables and sometimes to debug your code. Use return for logic and to return information to be processed or further utilized by the caller. Default parameters. Some variables need a sensible default value. In our greet function, the two parameters, name and subject, must be provided, or the function will not run. However, it makes sense to have a default value for the subject. Hence, we can redefine our function like this. Def greet name, subject equal to code with Festus. Return f string hello name, welcome to subject. Noun greet Sarah outputs hello Sarah, welcome to code with Festus. And calling with both parameters, greet Sarah Python tutorial will output hello Sarah, welcome to Python tutorial. If no value is provided for subject, Python uses the default code with Festus. Default parameters allow functions to work even when arguments are not provided. It is particularly important when the parameters should have a sensible default. Let's look at variable scopes. Variables defined inside a function are local. Variables defined outside are global. Outside the function, school equal to code with Festus. Inside the function, dev greet name, subject equal to empty quotation marks, classroom number equal to 5. Print hello name, welcome to subject or school, you are in classroom, classroom number. Here, school is global, everyone can see it. Classroom number is local, it only exists inside the function. Once the greeting is done, classroom number disappears but school variable remains. Local variables exist only inside the function. Understanding code prevents confusion, debugging bugs, and side effects. Let's take a practical approach to this. Imagine a teacher having the responsibility of registering students for a course or class. The teacher must ensure the records given by the student is accurate by set standards. The hypothetical scenario would be, a student walks into class and provides their personal information as, my name is John Doe, I am 15. But what if they only wrote their first name, wrote age in letters instead of numeric, or omit their age entirely? The teacher can't register unclear information, so instead of trusting every answer, the teacher creates a validation routine, starting with a name validator. Def get _ student _ name, open and close parenthesis, put colon. While true, name equal to input, enter your name. Strip, open and close quotation, split, open string, empty string, then close quotation. If len name less than 2, print, enter first and last name separated by space, continue. Return name. What's happening here? The teacher creates a function with a name, get _ student _ name. The function utilizes loop and keeps asking until the answer is valid. The strip is a Python string method that removes white space from a string, in this case the name entry from the user. The split with empty space inside quotation string is another string method that turns the string into a list by splitting at every space. The function proceeds to check if the length of the separated entry is less than 2. If it is, It tells the user that entry is wrong and uses continuous statement to restart the loop. Once the input is correct, the function returns the person's name as a list of strings. The process stops immediately because it encountered a return statement. Note, without return statement, the loop will run forever. Next, the teacher defines another function for validating age. Def get_student_age. While true, age equal to input, enter your age. If age is digit, return int age. Print invalid age, please enter a number. Just like the function for student name, the teacher keeps asking until the answer is valid. A string method .isDigit is used in this instance to check if the entry is a digit. Once the input is correct, the function returns the age as an integer. Notice the use of int age. The process stops immediately. Note the strategic places the return statement are placed in both functions. The functions combine. Loops keep asking, conditionals check validity, return values send confirmed data back. This is no longer just greeting students. We are verifying entries before registration. Let's consider an instance where there's an age restriction. The teacher decides to add an utility function that ensures the entered age is within acceptable range. Example, is the student within age? Def is valid age, open parenthesis, age. If age 12 less than or equal to age less than or equal to 21, return true, return false. This is a utility function. It does one small task, returns a clear true or false result, makes larger logic easier to read. Instead of writing if 12 less than or equal to age less than or equal to 21, we'll write if is_valid_age, open parenthesis age, close parenthesis. Now the teacher's intention is clear. Small functions like this makes programs easier to read and reason about. Now the classroom becomes structured. The teacher doesn't just accept whatever information given. The teacher validates the name, validates age, checks age is within acceptable range, confirms registration. The teacher knows the functions can call other functions and decides to create a function with a simple name that handles the entire registration process. Def register student. Name equal to get_student_name, open and close parenthesis. Age equal to get_student_age, open and close parenthesis. If name and is _valid_age, open parenthesis age. Print registration complete, else print failed to register student. Here's what's powerful. Register_student doesn't worry about how validation works. It simply delegates and uses the smaller functions to achieve its designed purpose. This is how real systems are built. Not one giant function, but small pieces working together. Function documentation. In Python, the convention is to use names to reflect the action to be performed by that function. But this name doesn't always describe properly what the function is meant to do. For this reason, Python has support for documenting a function. To demonstrate, place your cursor over Python's inbuilt function and methods we've used so far. Input, int, print, etc. You will notice VS Code displaying more information about those functions. But when you hover over our own functions, get_student_name, get_student_age, etc., you notice they lack details. Let's fix those by adding documentation to our own functions. Go to the line where we defined register student function. With your cursor placed at the end of the line, press enter key and type triple double quotation marks register new students, close triple quotation marks. Now you can hover over the function again and you notice that our new documentation is now displayed. You can go ahead and add documentations to the other functions as well. Note, Docstrings, function or method documentations must be the first line after function definition. It must be wrapped in triple, single or double quotation marks. You can also see function documentations using the inbuilt __doc__ method. Organizing code with modules. As the classroom grows, things get bigger and cluttered. Now we have name validation, age validation, registration logic, student records. Our current file still looks good, but as the program grows, putting everything in one file becomes messy. So we organize. Instead of one large script, we refactor into multiple files. Validation.py, registration.py, main.py. Think of it like validation desk, registration desk, main classroom. Example, validation.py. Here we put everything related to validating entries. Def get underscore student age, def get student underscore name, and the rest. Registration. Inside this file, we put logic about registering students. From validation, import get underscore student underscore age, comma get underscore student underscore name. Def register students. Main.py. Main.py can serve as the registration program's entry point. From registration, import register students. Then call the function register underscore students, open and close parentheses. Now the school operates like a structured institution. Don't forget that modules are simply a collection of related functions grouped together. This keeps code organized and maintainable. Now, how do you think in functions? When designing programs, think like a teacher organizing a class. Ask, what tasks repeats? That's greeting students. What logic belongs together? Validating information. What should this routine produce? A confirmed student record. Functions are not just code tools. They are thought organization tools. When you break a system into clear responsibilities, your program becomes easier to build and extend. To summarize, we started with a teacher repeating a generic "Hello, welcome to class" to every student. Now we have student validation, utility checks, coordinated registration processes, organized modules. That's the evolution of thinking in functions. At first, it feels simple, but soon you are building entire systems from small, reusable parts, and that is the turning point in programming. In the next lesson, we go deeper into structuring larger Python projects, turning your classroom into a full academic institution. Happy coding!